So we're back. So just so that's clear, I've done a quick drawing in between the two videos of what I call my perma post looks like. I'll put a couple of these in. Believe me, you can swing on those gates all you like. That post doesn't go anywhere. So that's what it looks like when it's finished. It's in the ground, obviously. This is ground level here. So these are your trenches. So we're about from end to end, anywhere between 1m20 and 1m50 either way. And about in between 40 centimeters and 60 centimeters deep. Okay, depending on the size of the gates you're going to be. If you're going to be putting 4 meter long gates on there, then you want to go a bit deeper. And this is a drawing of the rebar assembly. So that's trench rebar, which is 4 bits of rebar that are welded together with these little hoops like that. You can buy great big lengths of that for doing reinforcing around the edge of concrete buildings, and it's very, very useful. You can chop that up. Fit it together, like I said, to make that cross with the rebar coming up. So your rebar will be coming up out of the concrete, up about halfway up the post. And as you fill that trench up, that cross-shaped trench up with concrete, you can then drop the steel tube on the top, get that nice and level, get it pegged out with some string, and then continue filling up until it's filled up to the top with concrete. And like I said, that means you've then got a gate post that's capable of having 2 gates on it, one either side, without it swinging all over the place. Now, the alternative, for those who want to try, is to put a big old chestnut post in the ground, which means making a big old hole, or you need a tractor with a thumper to come around and get a post that size in the ground, and after about 10 years you are just going to have to replace it, and you will find that your gates, the post will start leaning out with the gates, and then the gate will drop into the ground, and opening and closing the gates becomes a horrendous, gut-wrenching physical chore. I've grown up on 2 farms as a child, spent a couple of years living in the city, a couple of cities, and I have spent the last 10 to 15 years living in the countryside. Believe me, gate posts, you do want to get that right, especially as we're going to plant trees and hedgerows everywhere. There's going to be a lot of roots in the ground, so if 10 years later you find yourself having to replace 42 gate posts and digging in where there's lots of root networks everywhere, you're just going to be spitting feathers. It's going to be no fun at all. Right, we're going to move the picture down now, because all that's very nice. That's a pattern that should work. My job is going to be able to create that on a slightly smaller scale and test it. There's always surprises. No matter what kind of procedure or design I work out, they always get something wrong. It doesn't mean that the design's a failure, it just means you need to rethink and modify things, and I want to create a model that works. I don't want people to be able to come and do copy and paste of it, but I want to be able to people to come and look at the pattern and then study and learn the pattern quite quickly, and then go off and apply the pattern to any piece of land, which we'll be coming to shortly. So there is a pattern within the pattern. This is going to be my succession pattern of how to put that in place, because you can't just click your fingers and make that happen. So this is what I've been working on for the last 6 years, in between other things, and this is the sequence of techniques that I'm putting into place now, and testing before then going to go on to a 2.5 hectare piece of land, and put this into place and debug the techniques before preparing a finished program. So on this side of the drawing, this is my succession. So we can imagine we've just bought the land. Obviously it's all been mown and pastured to death, well, not to death, but it could be in a lot better shape, and we're now, instead of leaving the cows on for 3 months at a time and then moving them and then setting it in for hay and driving around non-stop with a tractor and breaking the land down and compacting it and causing erosion and flash flooding and all this kind of rubbish, we're going to put it into that cell grazing technique, which if you want to know more about, you can look at Alan Savory's work and Joel Salatin's work as well. Some of Jeff Lawton's videos have got it in as well, some very good. This design this pattern definitely came out of one of Jeff's better videos. So we're going to put our large animals in electric fencing while we're waiting for the trees to grow. Now, the problem with electric fencing is that when you've got long grass, if the long grass touches the wire, well, the electric shorts out and the fence hasn't got enough juice in it to stop the animals breaking out. And if the animals break out, they will unfortunately ruin any other work that you're trying to get done at the same time. So we're trying to keep a happy balance, and we do want these cows to be moving from parcel to parcel. So we would conventionally, what I've seen happening, a couple of farms up in Brittany and Normandy, dairy farms that have gone into this cell grazing, is go out with a quad with a little trailer on it with all the fencing equipment and a strimmer, and strim out the perimeter of the field a couple of days in advance, set the fence up, move the cows into the paddock, and then strim another one and take the old fence away and put it on the next one. So you've got 2 sets of fencing. You definitely need 2 sets of fencing, and then there's constant strimming work strimming out to make sure that the grass is short on the perimeter so the fence can go up. Now personally, I absolutely hate strimmers and always have done. I am capable of using one, but that smell, especially in the springtime, of lush wet grass mixed with 2-stroke fumes actually makes me want to vomit. So been trying to work out a way of getting around that, and what I've come up with is something called the chicken caterpillar, which we can see a very, very rough representation of here, and I've got a better drawing here behind me somewhere where I'm going to explain it to you in better detail. Okay, the chicken caterpillar, I've started building the first one. It looks like this. Now I've built a few chicken tractors, several different ideas, and as an object to design and make, they are incredibly difficult. They need to be big, they need to be strong enough to be moved about, they need to be moved over rough terrain, through long grass. The idea is you want to put the chickens onto long grass and get them to scratch it down. If you're wheeling the thing about, to be honest, if you want to be using chicken tractors, you need to live on a golf course, okay? Even when you look at the Zaytuna chicken tractors with their up and down screw jacking trolley wheels and everything, just have a good look at the grass that they're on. Not criticising Zaytuna, it's a great project, but the chicken tractors, when you get onto real rough proper land, they're not a viable option like that. I've tried making wheelbarrow chicken tractors with some nice sturdy bike wheels. It's the same. There's always a hole somewhere. It's a rigid structure made of wood or made of metal, and there's always a hole somewhere, and the chickens get out. And a chicken that gets out in an hour, it can ruin a whole day's work for you if it gets into the veg plot. So this is the chicken caterpillar. The other problem with chicken tractors is they're not bloody big enough. Excuse my French. The chickens have a real hard time living in there. They're always up against the wire, going bug, bug, bug. When are you going to let me out? When are you going to let me out? They don't like it. So here we are on something a lot bigger, but that can be lightweight and movable. So I've broken it down into small pieces, and it makes these tunnels, these modules. Now these are 1.50 m wide and 1 meter long. They're made out of 14mm diameter rebar, all welded together. So I've worked out a process of manufacturing. I'm about halfway through the first one at the moment. Once that's all fitted together, you can pick it up by the top with 2 hands and you can move it. They weigh 12.5 kilos per module, so they're quite easy to move. And I've set the bottom bar here that the chicken wire is wrapped around and anchored to at 10 centimeters from the bottom of the risers. So that means that we've got 10 centimeters of metal that sticks out at the bottom, which means we can push it into the soil. So that means that even if the soil's a bit like this and a bit like that, every meter the modules will make up the difference, which will minimize the holes effect. You're gonna have to be some really rough terrain if there's going to be holes, so this should cover the holes. And the second advantage is that we can put it down onto long grass, whereas when we've got a wheeled contraption like this bit at the end, you need to push it through the long grass and you end up really struggling pushing the grass down, and it kind of defeats the object. So we've got these modules, we're going to stick them on the ground. We'll take our contour level out onto the land, mark out the contour lines, whether we want them on the level or at 2% or at 4% for our future swales. And once we've marked them out, we'll then follow the pegs with these modules. And I've made modules at 45 degrees, I'll be making at 22 degrees and at 11 degrees, and we can then make it turn and do lots of different things with it. Now some of the modules have also got a roof on them, so they've got wire and then they've got a plastic membrane. It's a woven plastic fabric that we use for putting on the roofs underneath the tiles and underneath slates, to let steam out, and if there are any leaks or anything, to keep water out as well. And on the ones that are covered, because that will be a rain collecting surface, well, obviously there's a bit of guttering which straddles the inside and the outside, so that rainwater runoff will fall in there and fill that up, and so that will make a water trough for the chickens. So if it does rain during the day, we don't need to bring water to the chickens. Obviously, if it doesn't rain, we need to come along with a watering can and just fill those up from the outside. Because it's straddled from inside to outside, we can fill it from the outside without opening the whole contraption. And then there's the house bit. This is a little bit more difficult. It's actually going to be the other way round. The wheels are going to be at the front, and then there's a guillotine trap to be able to let the chickens in and out, and inside there's a rack that the chickens can perch on, plus the laying boxes, and then there's some wheelbarrow handles sticking out of the end, so that when we move that, we can close the trap of a night time, move all the tunnels in the morning, set it up on the next position, and then just wheel the house along, clip the house onto it, open the trap, and then the chickens can come out. Okay, seen from above, it would be something like that. So there's the chicken house bit with the wheels, and then I would ideally put 2 modules that have got roofing material on them at the front, so that if it is a nasty, rainy, horrible day or lots of wind, the chickens can actually come and have some refuge in between outdoors and indoors. It's like a tampon zone there for them. And then the rest of them are just cages, so that's open to the sky. The sun can get in, the chickens can get to sun themselves, or they can get to hide from the sun and the wind. All of the corner modules will be covered. The idea is that if there's a corner, if it's a windy day, one of the corners will provide refuge from the wind, and maybe we'll put some more covered modules next to the corners, and of course at the end where there's a stop end that stops the chickens getting out of the end. Now the idea of this is to have 18 meters by 1 meter 50 of chicken run for 12 to 15 chickens which will live in the house. Now we can do lots of other bits with them. This will be my first usage of it. I'm doing some very small parcels on a small bit of garden land where I'll be running the chicken caterpillar round to trim the perimeter, and then I'll be putting up plastic chicken fence, electrifiable chicken fence, and I'll be putting ducks in there. So I'll be doing chickens in the tunnels to do the trimming, and then following around with ducks which will graze the land off. As we get up to bigger animals, we're going to need bigger parks, so we would need more chicken caterpillars, and the idea will be to have about 8 of them, and 8 chicken caterpillars will allow me to draw out on this pattern at this size with the 32 by 25 meter parks, would allow me to draw out this pattern. Now I've got 8 chicken caterpillars, each one with 15 chickens in it. That's 120 chickens, which means that on average, being quite conservative in the estimations, we're going to be producing 60 eggs a day just for strimming the perimeter. And it's a lot better than buying petrol and putting it in the strimmer and going out and working. It's going to take about the same amount of time to move all that as it is to strim round. Okay, and then we can put the fence up, and then we can move the cows in, and then move the chickens in, and then move the sheep in, etc, etc. It's going to be quite a lot of work in the beginning while we're waiting for the hedges to grow. The hedges, as they grow, will eliminate work. So we're going to be doing a lot of work in the beginning, just like Succession, nature working very hard to create a mature ecosystem. Now the second usage of the chicken caterpillar will be to prepare the swales. Okay, the first usage in the summer, so I've said strimming the perimeters. The second usage to prepare the swales. So we mark out our swale line with the level. We put the chicken caterpillar on contour or slightly off contour, depending on the tilt of the swale that we want to do. And we leave it there for 3 days. After 3 days, we move it just one place up the hill. And then after another 3 days, we move it down the hill. And we end up with 4 meter 50 by 18 meters long of strimmed area. Now between days 3 and 9, that gives us 6 days to go and cut the biomass, go and cut some grass, and pile it up on the middle row. And we'll carry on with that in the next video.